Have you ever wondered why you react the way you react in some situations, or why you feel some things like love, or other feelings like fear, or sadness, or pain, or why you feel with some actions like drawing or playing piano? Well, you will discover that today.
Okay, so we all know dopamine is a neurotransmitter that plays a vital role when it comes to cognitive functioning, memory, and motivation. In particular, high levels of dopamine are associated with feelings and pleasure, and also increased of levels of dopamine are responsible for feeling euphoria. At the same time, early stage romantic bliss leads to higher levels of stress, hormone cortisol, and lower um, amounts of stress busting that is a neurotransmitter of serotonin.
When we get scared, our brain taps a signal. That signal travels to the amygdala, a region of the brain that is near to the base. When our brain taps that signal, like it's very near to the base, we don't have control of that reaction. So we freeze, we jump, or even scream. But the difference is that when it gets to the second region of the brain, that is the hypothalamus and triggers, or blood pressure got high and pumps adrenaline through our bodies. That's the rush that we feel when we got scared.
This is how your brain works when you're in pain. The signals move rapidly up insulated nerve fibers to the brain's thalamus, which acts as a relay station and directs them to the sensory cortex. The signals are then interpreted by the brain as a sharp pain. The slower impulses traveling through the web like neural fibers become a throbbing ache felt through the entire body, a warning to treat the area usually while it heals.
Okay, how our brain works when we are drumming. Our brain, which is separated in two hemispheres like the right and the left, uh, is working together to create a shape, but the left is focused on the shape like circles, like basic stuff that make the structure of what are you drawing, and the right side is focused on the details like the clothes, the shadows, and the brightness. So this is how the brain works when we are drawing.
How your brain works when you play piano. In most people, the tip of the brain's central sulcus is either deeper on the right or on the left side, which then determines which hand is dominant. But when scientists scanned the brains of pianists, they found something different. Pianists had a demonstrably more symmetrical central sulcus than everyone else. Though they were born right or left-handed, their brains barely registered it because the pianist still had a dominant hand. Research speculated that their equal dip was not natural, but result because pianists are able to string their weak side to more closely match their dominant side. That means that a pianist is born also with a more abilitous hand, but when time passed and you practice piano and you play piano, both hands and both sides of the brain are the same abilities.